Hi everyone, in this video we'll solve some differential equations, initial value problems, IVP, and you have to find the general solution and particular solution for the given differential equation. In part A we have dy by dt equals the cube root of x, where y of 1 equals to 2. First you have to multiply the differential equation by dx, both sides. Then you can cancel dx with dx and you will get dy on the left hand side equals x to the 1/3 dx. Now you can integrate both sides, and the integration of dy, it means integration of 1 dy, and 1 is a constant, so it will be 1y. We have y equals the integration of x to the 1/3. You have to use the power rule, so you have to add up 1 to the power and divide by the same power plus c. After that you have to simplify and you will get y equals x to the 4/3 divided by 4/3 plus c. Rewrite the power as cube root. You will get y equals cube root of x to the 4th, and here flip the fraction in denominator. You will get 3/4 multiplied by the root plus c. So this is the general solution for the given differential equation, and if you want to find the particular solution you have to use the initial condition in the problem. Since we have y of 1 equals 2, this means the point 1 comma 2, so x equals 1 and y equals 2. So you have to replace x and y by their values and you will get 2 equals 3/4 multiplied by cube root of 1 to the 4th plus c, which give us that 2 equals 3/4 plus c, and by moving 3/4 to the left hand side you will get that c equals 2 minus 3/4, and that gives us 8/4. To rationalize the denominator, minus 3/4, which is 5/4. So this is the value of c. So the particular solution will be the same as the general solution, but you have to plug in the value of c in this solution. So you will get the particular solution y equals 3/4 multiplied by cube root of x to the 4th plus 5/4. Now in part B we have dy by dt equals 1/t, and we have initial condition y of -1 equals to 5, which means the point -1 and 5. And here the first step is to multiply by dt both sides. Now cancel dt with dt, you will get dy equals 1/t dt. To solve this equation you have to integrate both sides, and the integration of dy, it means integration of 1 dy, which is y equals the integration of 1/t, and the integration of 1/x is ln absolute value of x. So here we have ln of t plus c. Now this is the general solution for the given differential equation, and to find the particular solution you have to plug in the point here. So x equals to -1 and y equals to 5, and we will get 5 equals ln of absolute value of -1 plus c. So ln of absolute value of -1 means ln of 1, and this is give us 0, and total we have c equals 5. So this is the value of c. To find the particular solution you have to rewrite the general solution again with the value of c. So you will get y equals ln absolute value of t plus 5. Now in part C we have dy by dt equals t plus 1 divided by square root of t, and we have the initial condition y of 1 equal to 0. And this initial condition means the point 1 comma 0, which means x equals 1 and y equals 0. So first you have to multiply both sides by dt. Cancel dt with dt, you will get dy equals, now we can distribute the denominator for all terms in numerator, and you will get t to the first divided by t to the half plus 1 over t to the half dt. Integrate both sides. Here we have 1 dy, which is y, equals integration. You have to prepare the inside function before start the integration. So when we divide, you have to subtract the exponent. You will get t to the 1 minus half, which is half, then a plus here 1 over t to the half, it will be t to the negative half dt. And this means y equals, now you have to start the integration, and you have to use the power rule to find this integration. T to the half will be to the t to the half plus 1 divided by half plus 1. Then we have plus t to the negative half plus 1 divided by half plus 1 plus c. After that you have to simplify, and you'll get y equals, in denominator we have 3 over 2, and up we have 3 over 2, so it will be 2 over 3 square root of t cubed totally, and plus here we have minus half plus 1 t to the half, and down we have 1 over 2, so it will be 2 square root of t plus c. So this is the general solution for our equation, and to find the particular solution you have to plug in the point we have in the question, which is the initial condition. So you have to replace t by 1 and y by 0. So you'll get 0 equals 2 over 3 square root of 1 cubed plus 2 multiplied by square root of 1 plus c. So we have 0 equals 2 over 3 multiplied by 1 plus 2 multiplied by 1 plus c, and you'll get 0 equals, now 2 over 3 plus 2 we can write it as 6 over 3, we will get 8 over 3 plus c, which means that c equals negative 8 over 3. So if you want to get the particular solution for the given differential equation, it will be the same general solution. So you get y equals 2 over 3 square root of t cubed plus 2 square root of t, then minus 8 over 3. So this is the particular solution. In part D, we have the differential equation dy by dx equals 4e to the x, and we have the initial condition y of 0 equals to 1, which means the point 0 and 1, x equals 0, y equals 1. So first you have to multiply both sides by dx. Cancel dx with dx, you'll get dy equals to 4e to the x dx. Now you have to integrate both sides, and here we have integration of dy, which is 1 dy, so we have the integration y equals 4 multiplied by the integration of e to the x, and the integration of e to the x is the same function, e to the x plus c. This is the general solution for the given differential equation, and to find the particular solution you have to plug in the point 0, 1 in the given equation, and you'll get 1 equal 4e to the 0 plus c. As you know, e to the 0 is 1, so we have 4 plus c. By moving 4 to the left hand side, you will get c equals 1 minus 4, which is negative 3. So the particular solution will be the same as general solution, but you have to plug in the value of c. So we have y equals 4e to the x minus 3. In part E, we have dy by dx equals 4 multiplied by 3 to the x, and we have the initial condition y of 0 equals 0, which means the point 0, 0, x equals 0 and y equals 0. So first you have to multiply both sides by dx, and you will get dy equals 4 times 3 to the x dx. Integrate both sides. Here we have 1 dy, so the integration will be y equals the constant 4 multiplied by the integration of 3 to the x, and integration of 3 to the x is the same function 3 to the x divided by ln of 3 plus the constant of integration. So this is the general solution, and to find the particular you have to plug in the point you have in the question. So we have 0 equals 4 times 3 to the 0 divided by ln of 3 plus c. So we have 0 equals 3 to the 0 is 1, so we have 4 over ln 3 plus c. Move this to the left hand side and you'll get c equals minus 4 divided by ln of 3. So finally you have to find the particular solution, so you have to rewrite again the general solution with the given c value, and you will get 4 over ln of 3 multiplied by 3 to the x, then minus 4 divided by ln of 3. And if you take 4 over ln 3 as greatest common factor between the two terms, you will get y equals 4 over ln of 3 multiplied by 3 to the x minus 1. Now in part F, you have to find or to solve the differential equation dy by dt equals secant squared t minus sine t, and you have the initial condition y of pi over 4 equals to 1, which means the point pi over 4 comma 1. So this is x and this is y. So first you multiply both sides by dt, cancel dt with dt, you'll get dy equals secant squared of t minus sine of t dt. Now you have integrate both sides. Here we have 1 dy, so the integration will be y equals the integration of secant squared is tan t minus the integration of sine t is minus cosine t. We have minus here, so you will get plus cosine t plus c. So this is the general solution, and now you have to find the particular solution by plugging the point here in the given solution. So 1 equals so we have 1 equals tan of t, which is pi over 4, plus cosine pi over 4 plus c. Now 1 equals tan pi over 4 is 1, and cosine pi over 4 is 1 over square root of 2 plus c. Now cancel 1 with 1 and move 1 over square root of 2 to the left hand side. You will get the value of c, which is negative 1 over square root of 2. So to find the particular solution for the given differential equation, you have to write the same general solution, and you have to plug in the value of c. So this is the particular solution. Now in part G, we have dy by dm equals 3 over root of 1 minus m squared. And we have the initial condition y of square root of 3 over 2 equal to 0, which means the point radical 3 over 2 comma 0. So this is m and this is y, because the variables are m and y in the differential equation. So first you have to multiply by dm, both sides cancel, and you'll get dy equals 3 over square root of 1 minus m squared dm. Now next you have to integrate both sides. Here we have integration of 1y, which is y equals, now 3 over root of 1 minus m squared, we can write it as 3 multiplied by the integration of 1 over square root of 1 minus m squared. So it will be 3, and the integration of 1 over root 1 minus m squared is the inverse sine of m plus c. So this is the general solution for the differential equation. Now you have to plug in the initial condition, this point, in the general solution, and you'll get 0 equals 3 multiplied by the inverse sine of square root of 3 over 2 plus c. How to find the inverse sine of square root of 3 over 2? You have to pick the angle that have sine square root of 3 over 2, and this angle is 60, which is pi over 3 in radians. So you have to get 0 equals 3 multiplied by pi over 3 plus c. So cancel 3 with 3, you will get c equals negative pi. So to find the particular solution, you have again to write the general solution, and you have to replace c by its value. So y equals 3 inverse sine of m minus pi. So this is the particular solution of the given differential equation. In part H, we have dy by dx equal x squared minus 1 divided by x squared plus 1, and we have the initial condition y of 1 equals pi over 2, and this means the point 1 comma pi over 2. So x equals 1 and y equals pi over 2. So the first step, as in the previous parts, you have to multiply by dx both sides, and you will get dy equals x squared minus 1 divided by x squared plus 1 dx. Now you have to integrate both sides. Here we have 1 dy, so the integration will be y equals. Now you have to simplify the inside function here by using the long division. I will do the long division here. We have x squared minus 1 divided by x squared plus 1. We call the x squared minus 1 the dividend and x squared plus 1 the divisor. Now start the long division. X squared divided by x squared equals to 1. Multiply it by the divisor. You will get x squared plus 1. Now you have to change the sign of this expression. You'll get minus minus. X squared minus x squared equals 0. Minus 1 is negative 2. So the expression x squared minus 1 divided by x squared plus 1, it will be the quotient, which is 1, minus 2, which is the remainder, divided by the divisor x squared plus 1. So you have to integrate this function, and the integration of this function will be like this: integration of 1 minus dx minus 2 multiplied by integration of 1 over x squared plus 1 dx. And the integration of 1 here, sorry, we have y equals the integration of 1 is a constant, so it will be x minus 2, the integration of 1 over 1 plus x squared is the inverse tan of x plus c. So this is the general solution of the given differential equation, and you have to plug in the point here by the general solution to get the particular solution for the given differential equation. So we have pi over 2 equals 1 minus 2 tan inverse of 1 plus c. So we have pi over 2 equals 1 minus 2. Tan inverse of 1 is pi over 4 plus c. Now we can simplify. Now divide by 2 equals 1, divide by 2 equals 2. Move everything to the left hand side. You will get c equals pi over 2 plus pi over 2 minus 1. Pi over 2 plus pi over 2 is pi minus 1, so c equals pi minus 1. So this is the value of c. Now you have to find the particular solution for the given differential equation. It will be the same as the general solution, but you have to plug in the value of c. So y equal x minus 2 tan inverse of x plus pi minus 1. And that's it. Thank you.